Hello, my name is Jocelyn Isaias. I'm in Info 4670 for the summer 2020. This is my final term project. The title of my project is Text Mining and Clustering Amazon Musical Instrument Reviews in RapidMiner. It's a very long title, but that's exactly what we're doing. We're just taking reviews from Amazon, running it through RapidMiner, and seeing what we can find through text mining. Here's the overview of the agenda. First is an introduction into text mining and k-means clustering, what it is, what we use it for, and how it was used in this project. More about the data set, um, the specifics of it, the process of cleaning it, making it ready for analysis, about the project, which is the goals, the context I saw myself in the project, the questions that I had, putting it through RapidMiner and the process of that software, the results, what we found, what they mean, and then the conclusion of what text mining and k-means can do for our future. So here's the introduction. We're talking about text mining, which is also known as textual analysis. It's a way of extracting patterns from and meaning from a large volume of text. It's an AI concept that's also used in machine learning. It's basically teaching the computer what a word means so it can group it with other words with similar meanings. And how it does is it assigns like a certain number and value. It's a very deep concept, but we'll go into it a little bit later. K-means clustering is when the computer can figure out what the word means and put it together with words with similar meanings. It's putting those things together. So k-means clustering is a method of grouping points together with an inputted number, which is the k in k-means clustering. It's the number of groups or clusters that you want. And then from that, the computer basically guesses and then trial and error um, of measuring the distance until each one of the distances between the center of the clusters and the clusters themselves, and then trying to figure out if those are equal. It's a very tricky subject. I have a visual later on, but yeah, it's basically the computer has data points, which are the words in our reviews. They they guess where the center of each point is and then do a bunch of math to figure out where equal groups would be. At the bottom is a general statement. Text mining and clustering can help us filter through a large amount of information, like we're going to see, like reviews and tweets, to identify patterns and keywords to ultimately make better data driven decisions, which is usually the result in information science. The information we want to like make good decisions. How I look at it is what we're looking at here is the Library of Congress. It has 167 million items in it. So I'm just thinking of how daunting it would be to have a single question like how many Oreos stacked on top of each other would reach the moon, to have to go through 167 million items to try and figure out this question. It would raise the question, why can't I just put the information into a system? It can read it for me, and then I ask it a question, and then it brings me the answer. And in the modern times, we're used to a search engine, and that's what we've done. We've deployed crawlers that have gone out to the internet, read all of it for us, extracted their own keywords about what they think the content is about, and then brought it back to us. So when I ask a question, it matches up keywords. So that's kind of how I'd look at text mining. Um, Specifically, the data set that I used in this project was Amazon musical instrument reviews, musical instruments being guitars, pianos, up to band instruments, tubas, stuff like that. I extracted it from Kaggle.com. There are 10,000 plus rows, which is significantly less than 167 million items, but it's kind of the same idea. We have this large amount of textual information, and how can we just put it through a system that reads it for us and answers and helps us answer questions that we have. So these reviews stem from 2004 to 2014. Down below are the attributes. What is highlighted are the two attributes that I used the most to answer the questions that I thought were interesting. On the side here, this is the process of data cleaning. This data was actually pretty clean when I got it. I just added an about and key sheet, which the about shows everything that you're seeing on the left, all the information about the data. And then a key sheet, all of the column names were abbreviated, so just what the abbreviations are and what they mean. Some general housekeeping keeping of removing some brackets. There were no missing values to fill in, so I didn't have to fill in with any zeros or anything. I was given a Unix time, which I'm assuming is universal time. It has the time and date stamped into a really long number. So I just took that, converted it, and then um, made a different column that had day, month, and year. What this data set was missing that I really wished it had is it had these musical reviews or musical instrument reviews, but it didn't have the product names. It had Amazon has their own special ID, which each one was, if we took that number and put it into Amazon, it would tell us what product it was, but we would have to do it one by one, and I could not find a reference lookup that contained both the Amazon ID and the product name. I looked around, but I could not find it. Okay, so about the project. So I thought about being a musical instrument manufacturer that sells my instruments through Amazon, and kind of the questions I would have with that, like what are my customers saying about my instruments? Is there anything that I'm seeing in all of these reviews that could help me, manufacture my instruments more? And so I took these reviews that we just said, cleaned them, put them through RapidMiner, which is a software that does text mining and clustering for us, which is great. And down below, you can see the process that I kind of went through. And on the next slide, there are operators that will go into each one specifically. But this is the overview. All right, so to be more specific, these are our reviews. Here, we did a select attributes, which is I want to key in on one particular topic or one particular column, and that one was the text of the review. And then we told the software to process the document using something called a TF-IDF. This is basically seeing how many times the term shows up in this document mixed with how many times it appears in a collection of documents. And it's a number that it assigns to it. Then we tokenized it, which is basically taking a letter and adding on a symbol so it can be, counted and numbered and stuff like that. Transforming the cases is taking it, making lowercase, filtering out stop words like the, and, is, because it's not really going to be useful in anything that any of the answers we find. And then we filter the tokens by length, which is basically bring me any word that is between 4 and 99 characters. So we ran our reviews through RapidMiner, and we asked it to cluster it. For this one, I asked it to cluster it into 3 groups. And the cluster model here, this is how the computer would have guessed to put them in 3 different groups, starting or doing the 10,000. And then I have a visual in here so the way that K clustering works is they take the words of generally, they take the words of the review and make them into data points. They put all of these data points on a line, and then the computer just guesses and randomly puts special data points as the center of a cluster or the center of a group. And then what it does is it basically measures the data point to the nearest cluster, and then basically just does that over and over and over and over again until it can find something that's relatively equal, which is what we see on this performance vector. It's way easier with this visual here. But it gives us all these numbers. And what we can tell by this is the lower the number, the more that the clusters are tighter, which means that the terms are probably related. They got assigned a number, which is the word vector of the meaning of it, and those numbers are very close together. The Dave's Bolden down here, it just helps evaluate the clustering algorithm. It's all of these sums. It's just an average. So you're summing all of these and then putting it on top of how many there are in the first place. All right, so from the top, or from the last slide, we saw that based on all the clusters, that cluster 1 seemed to have the words that were very likely related. They were used together. And so doing that, sorting it here, we saw that a lot of those words were pedal, cable, sound, good, great, and quality. We also did it with cluster 0. I also did it with cluster 2, but it was the same result. It was basically guitar, great, works, good. Looking at this, we would think that this is pretty good. Like people are very likely using the word great with our pedal or our cable or a sound or quality. Oh, so to take this even further, I wanted to see, as the instrument manufacturer, of what people are saying to really highly rated reviews. So, like, yes, it's important to hear all of the reviews, but just from the top one, just to see what we are doing right. So I went ahead and I took the reviews, and I took only reviews that received a 4 or 5 overall rating. Those were the best of the best. And then I ran the numbers again. These are the numbers that we get. We went down from 10,000 to 9,000. That's how many were 3 and below. And then what this one told us is the lowest number here is going to be this one, right? Cluster 0. And so, but looking at all of these two, it looks very similar to the test we just ran. And we saw that the terms guitar, great, works, and good are still terms that seem to be very, very closely related. And these are the numbers doing that. So the conclusion of this is, I'm a instrument manufacturer. I have these questions about, like, I really need to know what my customers think of my instruments, and how am I going to do that? I have 10,000 of their reviews, and I can either take the time and read each one individually and have run the risk of missing some or getting tired or whatever, or I can feed it through a process that not only reads it for me, but it also ensures accuracy. That it's a computer, it doesn't mess up, stuff like that. And then we can use this information. We need that information to be as accurate as possible because we're using this information to observe customer behavior and in turn make predictions about what I would need to do next as an instrument manufacturer, to meet the needs of the musicians or the people, the just beginning musicians who buy my instruments and find enjoyment playing with them every day. Thank you.